Welcome to free classroom of Introduction to Computer Networks. Now we want to talk about Connection-Oriented Transport Layer Protocol, TCP. And later we will discuss segment structure, reliable data transfer of TCP, and flow control, connection management. Well, first of all, we have a quick overview of TCP. TCP provides point-to-point connection. So one sender and one receiver. This is called point-to-point connection. And for the connection, we will have the reliable data transfer. Therefore, we will have the in-order by-stream transmission. That says we don't have the message boundary, so that's why we have a by-stream. And we have a bi-directional data flow. That says this side and that side can put into a single message so that we can have the full duplex data. And we have the maximum segment size denoted by MSS. Well, for TCP, similar to go-back-N, GBN simply, we have a cumulative ACK. And like GBN, SR, selective repeat, we have a pipelining for TCP. Of course, later we will have a congestion control for TCP, and of course, shortly we will have the flow control. And TCP provides the connection oriented. So we have handshaking, and later we will check how to have the handshaking. Of course, later we will have the flow control. So it's a flow control version. Well, TCP segment structure. We have a source port number, destination port number. This seen in chapter 2. And we have a sequence number. Sequence number using the first byte of the segment. And we have a acknowledgement. So here we will use A to indicate it's a acknowledgement. So we will have the first byte of data we expect. So it's acknowledgement. And data here, of course, we have a checksum to check anything wrong or not. And we have an optional length. So you can count the header. So it should be 4 bytes. So we have 20 bytes in header. This is the minimal length. And we have a length of TCP header. And we have fields reset, synchronization, finish, fin for the connection management later. Of course, we have a flow control to fill in the field receive window. And we have a congestion notification. Later we will talk about congestion. So C, congestion, E, enabled. Well, right now let us have the sequence number for the reliable data transfer. Well, first byte and sequence number. So similar to GBN and selective repeat, this one sent and act, and this one sent not yet act, and this one can use but right now no data sent, and this one out of the window, so it won't be okay to use it. And we have acknowledgement. So acknowledgement we use cumulative add similar to GBN. Well, how to handle out-of-order segment later we will use the way by using GBN, selective repeat, and TCP feature itself feature, and then we have the way to handle out-of-order segments. But in the spec actually it says up to the implementer. So here we use the mixture of GBN, selective repeat, and TCP so that we have the way to handle out-of-order segments. Well, so we emphasize sequence number count in bytes. And here we have a single byte. So we may have a sequence number 42 and the 1 byte, so next one is 43. And sequence number here, sorry, expected next expected sequence number, so next one here. So next one. So this is a way to have the corresponding sequence number egg. And how about the new setting? If we have C, okay, and how about this one? Maybe I change it so it's C. So I change it to echo, not echo. We have a B and B, and we have a D and D, 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 D. So 1 byte, 2 byte, 3 byte. So for the current one, okay, no change. But here, sequence number same, no change. But here we have X same. But this one plus 2. So here we have this one. 81. And same sequence number. So next one should be sequence number 81. But X, it should be 46. So if we have the change, we will have the current sequence number and X. So you can check it. And let me check it quickly. Yeah, correct. So specifically, we have the value like this. We have the different value. All right, so if we have the different lengths, not a single byte, we have the value change like this. Well, right now, we want to have the timer setting. So we have the interval to set the timeout, timer value. So how to estimate? So longer than RTT for sure. And RTT varies, so we need to estimate later. And if the timeout value set it to too short, then we will face the premature timeout. And too long, then we will result in the slow reaction to the segment loss. Well, how to estimate RTT? This is a formula. And we have the recursive formula. The previous stage estimated RTT, the current stage estimated RTT, and we have the current sample RTT using the weighted sum. So we can have a recursive formula to have the timeout estimate, the RTT estimation. And this kind of estimation, we call it the exponential weighted moving average. And for the weighting factor, we set it to alpha, and alpha we usually use a typical value 1f. And so that we have the smooth one. And this is the spikes. Because of a sample one, so we have spikes. But using the moving average, it will have the smooth estimate of RTT. Well, we have the estimated RTT, but how to have the setting for the timer? We will have a safety margin. Safety margin, how to have the safety margin? We will use statistic. So that we will have 3 or 4. Here we set it to 4. Actual value, we set it to deviation of RTT. So we have the similar approach to have the estimation of deviation of RTT. This formula again, but we have a different weighting factor, and we have actually the difference, and so that we have the deviation. Well, so we have the timer setting, and right now we can have the possible example to illustrate how we have the message exchange for the TCP sender and receiver. Of course, for the sender, we should have the sequence number, and it's a byte stream. Previously, we didn't know, and we will set timer for the oldest and X segment. Of course, we have the timeout interval estimation based on the previous approach. And of course, if we have a timeout, then we just resend the oldest and X segment, not all. So here, timeout follows the selective repeat. And of course, after retransmission, the oldest segment, we need to have the restart timer. And once we have receipt, and then we will check, should we have the continuous segment received? If yes, then we will deliver. Here, the uncontinuous. Actually, here it's somewhat hard because we have the jump, but how to make sure that is a continuous one? Actually, we're based on the next is patty egg. So here, this is the egg generation just for your reference. And let us have the following scenario. How about the first one? We send the segment but egg loss, so we will resend. So for this one, finally it's okay. This one, we have a lost egg scenario. And this one, we have a premature timeout. So timeout earlier. Then we need to resend. Resend because the first one now received, so resend. And resend, timeout, resend the oldest one. You see, oldest one. Oldest segment, not old, so resend the oldest one. And after receive, so up to now, we have act to 120. So act 120 sent again. And this scenario, we have the cumulative act if the first act cannot be received properly and just receive the second one. Is okay? Yes, it's okay because reach it to 120, so we can use 120 to send the next segment. And the next one, it's the feature of TCP itself. We have the fast retransmission. What that means, fast retransmission. Well, we don't use the timeout, and we use this one to indicate, yeah, something wrong with the oldest segment. And here we have egg 100 and duplicate egg. duplicate X. Duplicate X. We have 3 duplicate X, and then we think something wrong with the oldest segment. Which one oldest segment? This one. And actually it's this one, 100, right? 100. So after 3 duplicate X, then we resend that oldest segment, this one. And so that we have the retransmission for this lost segment. This is the oldest one currently. You can pass on the number of X, and then you will know which one. That one, just that one, not like GBN to retransmit old. So fast retransmit, we follow this idea. 3 additional S for the same data. So we have 4 X, the same S, but we have 3 duplicate X, and then we will initiate the retransmission for that segment. All right, so currently we finished the discussion for segment structure, reliable data transfer for TCP, and now data check flow control, and later we will check connection management. Flow control, we should determine when or how to maybe limit the sender to send proper amount of data. So think about the current question. If we have data slower, but transmission faster, is okay, sure. But reverse it, this one more, and this one slow. Oh, sorry, we mentioned this only. And so that the receiver cannot tolerate, and is okay, not okay. So here, if too many, not acceptable. So you have some daily life like this. Well, so flow control will want to control receiver. Receiver control the sender so that the sender won't overflow. Sender will overflow the receiver buffer. So how to set it? We can use the OS to have the receive buffer size minus the buffer data size, so that we can obtain the receive window. Use the receive window and to fill in the field in the receive window of the TCP segment. So we can use that information to throttle the rate sent by the sender. So we can use that way to have the flow control. You see this one? Well, right now, let us have the further discussion about the connection management of TCP. Sure, we need to agree to establish connection, and of course, we should agree with the connection parameters. For example, for the starting sequence number, actually, it doesn't mean we have the value from 1. Actually, we can have the negotiation, or maybe using a random value. If we can have, we can agree that setting. And in chapter 2, we can have the circuit creation. So we have this, and so that we can know, okay, client with the circuit, and the circuit connect to the server will be connected or not. So of course we should accept at the server side. Well, about the connection, in the past we didn't have a 3-way handshaking. It's correct. But right now we try to have some possible scenario to challenge. Is it okay to use 2-way handshake? Of course no, but we show you step by step to let you know it is not okay. 2-way handshake, it's okay for Alice. But another 2-way, then okay for Bob. So in total, it should be 1, 2, and 3. This one counting in a single one, so it's 2. So actually two-way handshakes. Put them together, then we should have the 3-way handshake. But right now, we still insist. Is it true? 2-way handshake can work normally? Actually, no. So for the current mapping, actually we have the connection request. and accept the connection. So in the internet, we do that thing, and we want to make sure, well, two-way handshake always work in network? Of course, no. Why? Of course, no, because we have a variable delay. Message will be retransmitted passively, and message will be reordered, and we cannot know each other, so we may have some trouble. So normally for this one, currently the order, it won't be changed, so everything's okay. So seems to be okay, but is it possible to have the scenario like this? Yes, for some reason. Oh, we should have the reconnection. Now, okay, so we will have the half open, right? Half open connection, no client for the current situation, so it is not okay. And how about retransmit the required connection and also retransmit the data? Same, not okay, because something wrong. So because of that, we don't like to apply two-way handshake. We want to apply the best one, so that we will accept three-way handshake, this one. And three-way handshake, so for client side connection establishment, we set the bit SYN, and we set ACK. Actually, it's SYN. So this one is SYN ACK. And finally, it's ACK again. So, okay for client. And right now, okay for server. So how many ways? 3 ways, and then we can have the connection establishment. So this is a 3-way handshake for TCP. And the 3-way handshake for daily life, yes, we can have a climber to make sure everything's okay. So the climber make sure on belay, make sure, and we have the response, yes, belay on. So climber feels safe. And the next one, the climber saying, okay, I'm climbing. So this one, make sure, okay, everything's okay for the current setting using the 3-way handshake protocol for the daily life. For example, climbing. Well, finally, after the connection, of course, we will tear down the connection to close the connection. And how to close it? We will set fin bit and then close it fin. And with ACK, then close. So we can have a client to close the connection. Or maybe we can close by the server. But close by the server for the client here. For the client, it should wait for actual amount of time, and so that it can close the connection totally, or otherwise maybe some possible segment may be sent, and then the client won't receive it. So we have a remark. Actual time. Actual reasonable time. Required. Here. If we have the server to initiate the connection closure. Alright, so this is the TCP discussion today, maybe for the different order, maybe for the wrong language setting. So I try the new discussion again. And hopefully everything will be okay, and you can enjoy the video finally. Alright, that's all. So this is Unit 4 TCP in Chapter 3. Alright, that's it, and see you. Bye-bye.